Okay, OOPS concepts. So earlier we've already had a look at the different OOPS concepts we have, and we've seen what a basic definition of each of these concepts is. So here in this section, I'm going to try and give a little more detailed information on these OOPS concepts, and we're going to see how you actually implement these concepts in your programming. Okay, so let's start off with abstraction, which is the first on the list. So we've seen that the basic definition of abstraction is hiding certain details and showing only the essential details. So let's see what this really means and how do you apply this in your programming. Okay. So if you have a look at the current slide, I've got two boxes out there with some code in it. And the first box, I have a class called shape, public class shape, which is abstract. So this is an abstract class, right? And within this class, I've got an attribute called color, which talks about the color of the shape. And it has also got a method called getArea, which is again public, and it returns a double. Okay, and if you have a closer look at this method getArea, you can observe that I have not given any implementation to this method getArea. In fact, I have simply ended it with a semicolon, and I also have given the abstract modifier as well to the method, right? So why did I give the abstract modifier? So if I hadn't given my method an abstract modifier, I should compulsory give an implementation to my method, right? So if I don't have an abstract modifier to my method and I don't give an implementation and simply try to end it with a semicolon, the compiler is going to throw an error, right? It's going to say I'm not getting an implementation to this method. So because I have that abstract modifier out there for my class, for my method, I can skip giving an implementation to my method and can simply give a semicolon at the end without giving any implementation, right? So now we'll discuss why I have given the abstract modifier to the method getArea in a moment. But before that, let me tell you why my class is also abstract, right? So the basic rule is, in your class, if you have at least one abstract method, your class should also be abstract, right? So that's the reason my class shape is also abstract now, because I have a method called abstract method, which is called getArea, right? Now let's discuss, why did I have an abstract modifier for my getArea method? Why is my getArea method abstract? Why didn't I give an implementation to my method? Okay. The reason is there are a lot of shapes out there, right? You've got a square, rectangle, triangle, circle, and n number of shapes, right? And purely without knowing, so a shape is a very generic term, right? It doesn't really represent a particular shape like a triangle or rectangle. And purely based on this information, I cannot determine the area of the shape, right? So I definitely need to know what type of shape this is. So I have different formulas to determine the shape, the area of the shape based on the type of the shape. So say for example, the shape of a rectangle is nothing but length into breadth, and a shape of square is nothing but side square. A shape of a triangle is half into breadth into height. So depending on the type of the shape, my formula to create the area or to get the area of the shape also changes. So for this class shape, I cannot really give a generic implementation of the getArea method. So for that reason, I have given an abstract modifier to my method getArea and given no implementation to this method in my shape class. But whichever class is going to extend from my class called shape is going to give an implementation, right? Alright, so one rule we saw is, so basically that was the reason I did not give any implementation to my getArea method, and I've put that as abstract, right? Okay, so we've seen one rule, that if you have at least one abstract method in your class should also be abstract, right? So there's one more rule to this now. If you are extending from a class which is abstract, right? So if at all I had a class called triangle which extends shape, right, I should implement all the abstract methods from my superclass. So if I have written a class called triangle extends shape, then for sure I need to implement the get area method in my triangle class. For sure I need to give an implementation to the get area method in my triangle class, right? If not, my compiler is again going to give me an error saying that you have not implemented all the methods from your superclass, abstract superclass. Okay, so that's one more rule you have when you talk about abstract. Okay, so now let's go back to the definition. So abstraction says hide certain details and show only the essential details, right? So what are we hiding here? We are actually hiding the implementation of the method get area, and we are only showing the essential details. We are showing that every shape does have a get area method. So there should be a method called get area for every shape. You should have the ability to get the area of a shape. So we are saying that we are just showing the essential details, but we are going to hide certain details like the implementation of the actual way to get the area of the shape, and that would be implemented by the subclasses which extend from the shape class. So that's abstraction all about. Okay, right. So when we talk about abstract classes, we always have one more topic in picture which we need to talk about, and that's interfaces, right? So what is an interface? So basically an interface is nothing but it's similar to class. It's got structure like class, but in an interface all the attributes should have public static final modifier, right? And all the methods should be public abstract methods. So this is actually a typo. It should be public, not string there. Okay, so all the methods are public static final, and all the attributes are public static final, and all the methods are public abstract methods, right? So that's the only difference between, if you're talking about code wise, that's the only difference between a class and a interface. In a class you can have different kind of modifiers for your attributes and methods and stuff like that, but in an interface it's always public static final for attributes, and it's always public abstract methods for methods, right? And what does it mean? It means that any class which implements this interface should give an implementation to all the methods present in the interface, right? So basically when you have superclass subclass kind of relationship, if you're talking about classes, a class extends another class, so a subclass extends a superclass. So that's the syntax you give when you're trying to give a superclass subclass behavior. When you're trying to write a class, when you're writing the subclass to the shape class, you write public class triangle extends shape. But at the same time, if my shape is not a class, it's an interface, so what would my subclass look like? My subclass would then look like public static triangle implements shape. So you extend classes and you implement interfaces, right? So one advantage you have when you are implementing interfaces, you can implement a number of interfaces, right? And at the same time you can extend some class as well. So you know that we have this limitation in Java where you cannot implement multiple inheritance. So that means you cannot have a particular class extending from two classes, right? So say for example, I have a class called shape and I have another class called something else, circle. So I cannot have a class called semicircle and I say semicircle extends shape comma circle. That's not allowed in Java. You can have only one superclass, in Java, right? So you can only have shape or a circle as your superclass. So when you come to interfaces, you can implement multiple interfaces, right? So, and you can implement interface, and at the same time you can extend a class as well. So that's one important difference between interfaces and abstract classes as well. So when you have some other classes as well to be extended from, you can always go for interfaces. Okay. But let's talk conceptually now. Conceptually, what's the difference between a class and what's the difference between abstract class and interface, and when do you use which one? Okay. So let's have a look at this. So we know that a subclass is, when you say a subclass, you are saying that this class is a special version of my superclass, right? So say for example, I've got a class called car, right? And I've got a class called Nissan. So Nissan is a car, right? So Nissan is nothing but it's a special version of car. So in a scenario where you have an either relationship, you always have a class, superclass, subclass relationship, right? So if at all you have a doubt whether my car class should be a class or should it be an interface, you should do this check. You should try to determine whether you have an easier relationship with your subclasses or not. So my Nissan car is a car, so I've got an easier relationship there. So that means my car should be a class here and should be an abstract class. Okay. Now let's come to interfaces. When do you go for interfaces? So basically, when you talk about interfaces, you're talking about certain behavior, right? So let's say you have a behavior called bounceable. So anything that has the ability to bounce is bounceable, right? So you've basically got a ball, a tennis ball, which is bounceable. You can bounce a tennis ball, right? At the same time, you even have a car tire. A car tire can be bounced as well. When you put it on the ground, it's going to bounce. So that is also bounceable. But these two are completely different classes, right? They don't come from the same tree hierarchy of classes. They come from two different hierarchy of classes, but they have a common feature or behavior between them, and that feature is nothing but bounceable. So basically, you create an interface called bounceable and you implement this interface bounceable in both your ball, tennis ball, as well as car tire classes, right? So this is a common feature which two different classes of entirely different hierarchy have in common. Okay, so that's the basic difference about abstract classes and interfaces. Okay, next up on the OOPS concepts is encapsulation. Okay, so before we go ahead with discussing encapsulation, I'd just like to put forward a small scenario in front of you, which would actually help us better in understanding the concept of encapsulation. So let's assume that you have a YouTube account, right? And you have a lot of videos uploaded out there. Okay, and today you uploaded two more new videos to your account. So the first video is about your cute cat. So your cat did something funny today and you found it very hilarious. So you just shot a video and you put that up on YouTube. Okay, and the second video is about your Hawaii trip. So you recently went to a trip to Hawaii and you had a very nice moment there, and you captured some good moments on the camera as well there, and you put that up on YouTube. Okay, but these two videos are of different categories, right? Coming to your cat video, you really don't care if anyone is viewing that video or not, right? In fact, you would like to share this video with everyone so that anyone can watch that video and have a good laugh as well, right? But when it comes to Hawaii trip, this is something very personal to you, and you would not like anyone and everyone to view this video, right? You would only want some of your very close friends and family to view this video, to watch this video, right? So what are you going to do now? You will go to your settings and you're going to mark the cat video as public so that anyone can view that, and you're going to mark your Hawaii trip video as private, right? Because you don't want anyone to see this video, and you give only privileged access to some of your close friends and family to watch this video, right? So this is exactly the same concept of encapsulation. So what you are doing here is nothing but you are hiding certain data from the rest of the world and providing only privileged access to that information, right? So let's go to the encapsulation. Encapsulation, the definition says binding data and methods together. So basically the end product of that is nothing but data hiding, right? When I say binding data and methods together, I mean that there is a strong relationship between the data and the methods of the object of the class, right? So there is a tight coupling between the data and the methods, so they are dependent on each other, right? Okay, so let's take this example. I have a class called employee, okay, and I have two attributes in the employee class. I've got the employee name and I've got the salary, employee salary, right? So employee salary is one thing which is very sensitive information, right? You wouldn't even want someone to see what the salary of a person is, right? Just put apart the scenario of allowing persons to set the value of salary or set salary for a person. You don't even want to allow persons to view the salary of a person, right? So you are here now imposing strict privilege constraints on your salary attribute, right? So you've got getter and setter methods for salary here. So the getter method actually takes a role as the argument, and it checks if only the person is a manager, I am going to return the salary value to the person, right? If not, I'm not going to return the salary to the person, right? So that's the check you are going to make when you are implementing the get salary method. So what about set salary method? Who can set a salary to a person? Can the employee himself set salary? No. Can the manager set a salary to his employee? No. The admin? Yes, probably yes, right? So I'm going to check the role again here and set salary as well. So if the role is an admin, if the person who is calling the set salary method is an admin, then only I'm going to allow the person to set the salary to some new value. Okay. So here what I'm doing is, so can anyone directly access the salary attribute from outside this class? No. Why? Because I've marked it as private. So the only way they can access the salary is using the public getter and setter methods, right? So this is how you actually implement encapsulation. You give a private attribute, you mark your attribute as private and provide getter and setter methods, public getter and setter methods, and within your getter and setter methods you again put some conditions, lot of checks to verify that the person who's actually making the call is an authorized person and has the right to get access to that particular attribute in question, right? Okay, inheritance. So what is inheritance? Inheritance is nothing but inheriting the features of the superclass, right? So when I say features of a superclass, what do I mean? Features are nothing but attributes and methods of the superclass. So I'm inheriting nothing but attributes and methods of a superclass. Okay. So let's take an example here. I have a class called car, right? And it has got attributes max speed and color, and it's got a method called get save speed. So basically every car has these attributes and methods, and there are a number of other attributes and methods as well which we've not given here, right? Now let's take an example of a specialized version of a car. So Nissan is nothing but a special version of a car. So it is a car and it is a subclass of a car for that reason, right? So I say public class Nissan extends car. So car is a superclass and Nissan is a subclass here. And I have a attribute called intelligent key in the Nissan class, and probably this is something special only to Nissan and it's not present in all other cars. So for that reason, intelligent key is not part of car, but it's part of Nissan, right? But along with intelligent key attribute, the Nissan car will also have all these attributes and methods as well. So basically Nissan inherits all these attributes and methods from the superclass in its own class. So anyone from outside this class or from the outside world, if they try to get the color from the Nissan class, they'll be able to fetch it. It won't give them an error because it has inherited all those features from the superclass. Okay, so basically this is inheritance all about. So whatever common things you have, you put them in the superclass, and whatever things that are not common, which are special to some subclasses, you put those things in the subclass, right? Okay. Polymorphism. Polymorphism is one name having many forms. So let's have a look at an example here to understand what this really means. Okay. I'm going to take the same example here. I've got this class called shape. This is an abstract class, and it has got an abstract method called getArea, right? And I have two other classes as well, square and rectangle, which are nothing but subclasses of the class shape, and they also have an implementation of the getArea method. So since it implements the abstract class, since it extends the abstract class, it should implement the methods of the superclass. So I've given implementation to the getArea method in square as well as rectangle. So if you have a look at the getArea method implementation in square, it again internally calls another getArea method and passes an argument 1, which is nothing but the side of the square. That returns the area of the square as side to side. So I'm defaulting the side to 1 if there is no arguments passed. Right. Similarly for rectangle, the getArea implementation calls the getArea method, which takes 2 arguments, the length and the breadth, and I'm again defaulting the length and breadth to 1 and 1, and it returns the area as length into breadth. Right. So if you have a look here, I've got the same method named getArea, but I've got so many different implementations for the method getArea. So I've got only one getArea name, but I've got 5 different implementations and forms of the getArea method. Right? So this is nothing but polymorphism. Okay, so I would like to introduce two things here, two concepts: overloading and overriding. So what is overloading and riding? So if you have a look at the method signature of this getArea method in the superclass, it's got a public modifier, it returns an integer, and the name of the method is getArea and doesn't take any arguments. Similarly, in square and rectangle as well, we've got a method with similar signature, right? Absolutely same. So this is public modifier, returns an integer, and the method name is getArea and doesn't take any arguments. So when we have such a scenario where in the subclass the method has got the same method name and signature and return type and number of arguments, it is called an overridden method. So basically this is an overridden method for the getArea method in the superclass. Similarly, this is also an overridden method in the rectangle class for the getArea method in the superclass shape, right? So we have this overriding thing come into picture only when we have a superclass subclass kind of a relationship, right? Now let's talk about overloading. What is overloading? When in overriding everything should be same, in overloading you can only have the method name as same. So only restriction you have is the method name should be same, and you can have different return types, you can have different number of arguments, right? So here, since the method name is same but the number of arguments is different than that of the superclass method, this is called overloading. Or in fact, this could be an overloaded method to this getArea method as well, right? Similarly, this is also an overloaded method, right? So these internally are overloaded methods, but when you talk about this and this, they are overridden methods, right? So when you talk about overloading, you can have many overloaded methods in the same class itself, right? Whereas in overriding, you cannot have them in the same class. It has to be in the subclass superclass kind of relationship. Okay. Right. So runtime versus compile time polymorphism. So what is runtime polymorphism? What is compile time polymorphism? Let's take some examples here to actually understand the difference between runtime and compile time polymorphisms. Okay. So here again I'm taking the same example, shape, class shape, and I've only got class square which extends shape, and I've removed the getArea methods, and the shape class is no more abstract now, it's a normal class, and both have a display method which prints, this prints in shape, and when in square the display method prints in square, right? So let's have a look at what are the different ways we can instantiate these objects and call the methods on these objects, right? So I've taken 4 different scenarios here. Right? In the first scenario, I'm creating an instance, a reference of shape class and object of shape class as well. So whatever is on the left of the equal to the new, right, is called a reference, and whatever is to the right is called the object, right? So the reference of shape, object of shape, I'm calling s1.display. Pretty straightforward, right? So this s1 is going to print in shape, right? Number 2, reference of square, object of square, s2.display. This is again pretty straightforward, and this should display, s2 should display in square, right? Now I'm creating a reference of shape but an object of square, and I'm calling s3.display. So what should happen? Should it call the display method in shape class, or should it call the display method in the square class, or should it give a compile time error? So what's the result of the s3 thing, s3.display? Let's have a look at this. So s3, this is nothing but, this reference is nothing but is of type shape, right? But it is pointing to, this is pointing to square object, right? Can it point to a square object? Basic. Yes. Why? Because square is a subclass and shape is a superclass. So always you can have a reference of a superclass holding a subclass object, right? Because a superclass can hold any object of a subclass in it, right? But the reverse is not true, right? So when you call s3.display, which display method will be called? The method in the square class will be called, because you are creating an object of the square class. So irrespective of the reference type, whatever type of object you create, the method will be called on the type of object you created. So you created an object of square, so the method, when you invoke this display method, even though the reference is referring to the shape class, it actually at runtime calls the method on square. So it 3 displays in square, right? Okay, now 4. Let's see what happens here. I've got a reference of square and I'm creating an object of shape, and I'm calling s4.display. So what should happen now? So if you have a look here, s4 is nothing but is a reference of square, but it's trying to refer to shape, which is nothing but a superclass, right? So this is not allowed. So this is not allowed. You cannot have a reference of a subclass holding an object of a superclass, right? this is not allowed. You are going to get a compile time error here when you try to do this. Okay, so let's take a simple scenario in a family, like you have parents and you have kids, right? So kids cannot overrule parents, right? But parents can overrule kids. So that's kind of simple analogy to this. So basically a subclass cannot hold a subclass reference cannot hold a superclass object, but a superclass reference can hold a subclass object, right? So these are the different scenarios which you can have when you have subclass superclass relationship, and this is how it invokes the different methods on the superclass or subclass. But we have not discussed what compile time polymorphism. We've just seen what runtime polymorphism is, right? Runtime polymorphism, actually it determines from which class the method should be called. So that is determined by the runtime polymorphism. So in number 3, the reference is of type shape, but object is of type square, but ultimately it calls the method from the square class. So that is determined by the runtime polymorphism, right? But what is compile time polymorphism? So when you say shape s3 is equal to new square, right, and let's say for example this method display was not there in the shape method, right, and it was only there in the present in the square method, what would have happened? We know that at runtime it's going to call the display method of the square class, right? So I still have the display method in the square class. Is it going to compile and still display in square? No, it wouldn't. Why? Because since we are having a reference of type shape, the method display should be present in the shape class as well, because when Java is compiling your code, it always checks for the method in the reference type class, but not the object, right? So when it is actually compiling your code, it checks whether the method display is present in your shape class, which is of the reference type. But ultimately when it executes the method, it takes it from the square class, right? So this is what compile time polymorphism and runtime polymorphism all about.